Hi, everyone. Thanks for joining this talk. Hope you're enjoying Connect. I'm Ganesh Raju, again, tech lead for Big Data and Data Science team in Linaro. And this is the agenda that we will be covering today. I'll go over a quick overview of the whole big data ecosystem. I'll be talking about the high-level goals of our team in Linaro. And we will see some misconceptions on ARM that is out there that we have faced while tackling many tasks working on ARM ecosystem. The approach that we have, the Linaro team have been taking, some general pain points, challenges that we have faced. Then we will see what where we stand right now from Linaro's team status and towards ARM in general in big data and data science space. Then we will cover what we have in plan as roadmap. Okay, so for those who are not familiar with big data technologies, it is a huge ecosystem with many complex and redundant projects, both open source and proprietary. You can actually categorize all these different projects or components that we call in big data world into core components like Hadoop, Yarn, Zookeeper, Scoop, and operational components like Ambari, then data ingestion components. Then we have streaming components where you do processing in memory like Spark and Flink. Then you have data warehousing components like HBase, Cassandra. And then you have NoSQL databases. And on top of it, you have file formats like Avro and Parquet. Then you have visualization tools or data dashboard tools. And you also have components that focus on big data security and governance. And then you have data science tools and notebooks like Jupyter, where you can interact with data and do data science and machine learning with it. So like you can see that how large the ecosystem is. So to tackle this huge ecosystem and to make sure ARM is a first-class citizen with all these projects, we split the work into 3 high-level goals. And our Jira tickets in Linaro aligns with these goals. Number 1 is the build and port effort that is required with each project. Part of the task is to work with upstream project and set up CI with them by providing ARM hardware if it is required and to automate tests, and also provide multi-arc Docker images. Number 2 is to do benchmarking, and number 3 is to focus on opportunities to optimize for ARM-specific advantages. Majority of our work goes into number 1 task, which is build and port. Okay, so misconceptions, a little bit of history. So when we started off on these tasks a few years ago, we ran into many hurdles and noticed few misconceptions out there. So when we started to approach some of these projects to see if they have ARM support already, some of the questions that we faced were like, isn't ARM Raspberry Pi? And many projects were not familiar actually with the ARM ecosystem at all. So projects thought ARM was not production ready or anywhere close. Many projects didn't have the required hardware, even if they were interested to put efforts. And the most common misconception was, isn't it all Java? And it should have no problem running anywhere. So even though majority of the big data projects are actually Java, this is not really true. We have seen projects where it's hard-coded, it has hard-coded logic specific for just x86 architecture. And there is a if condition looking for x86, but there is no else if conditions. Moreover, many projects have many dependencies that didn't have ARM bits available, and many projects were reluctant to uh, do the additional testing efforts that would be required, and therefore, there was lack of interest. So the approach that we took to look at this large ecosystem and tackle each project were to actually split this whole work, and we took top to bottom and bottom to top approach. So what that means is, there are certain components, like, for example, Bigtop and Apache Ambari. Apache Ambari specifically as an operational component that actually works across many big data projects. Meanwhile, looking at each individual components as well, like Apache, Hadoop, Spark, Arrow, Beam, NiFi, and also looking at data science projects like TensorFlow and Anaconda and things like that. So we chose Apache Bigtop, and it has been very important component where we have been putting majority of our efforts. Bigtop is an umbrella project which supports packaging, configuring, testing, and installing many, and it covers majority of the big data projects. We have been working on this, and we have made quite a lot of progress if you see from where we started, actually. And this slide actually shows what Bigtop consists. It consists over 25 of the top level big data projects. And it is the only open source alternative that is currently available in the market. It is the foundation of many big data distros out there. For example, from Cloudera, AWS, or Red Hat. And because of this, it has been very, very important for the ARM ecosystem and for Lenovo's big data team to focus on this. So some of the achievements, in particular to Bigtop, that we have done in the past, we have made quite a lot of progress. We have been submitting so many patches. So if you see from where we started with having no ARM bits at all to now, now that we are leading majority of the efforts in the project, with the current version in particular, we have brought in Elastic's search stack into Bigtop. Thanks for Junhei and Yuchi from ARM for their efforts. And our contributions to Bigtop has received due respect or recognition with the project. And Junhei is recognized as the chair of Bigtop PMC. He has also filled in release management role in the past. And Yuchi is the maintainer for Bigtop. So our patches have gone into many components in Bigtop. Especially, we have worked quite a lot on smoke test, integration test, adding this test coverage across all those components in Bigtop, and also in establishing CI with the project itself. So this is just a quick timeline of our contributions in Bigtop when we started in 2016, where we didn't have any kind of ARM support, to 2017, where we actually had our first successful build on Debian and Ubuntu. Then moving on to 2018, 2017 is when we had version 1.2 released with majority of the components having AR support. And then 2018, we worked with the upstream project in setting up CI with them by donating our developer cloud instances and helping them to set up and run their build and test and our ARM architecture, and thanks to Marcin from Red Hat in helping with that. In 2018, November, version 1.3 is when Bigtop announced official support for ARM, and ARM became first-class citizen with the project. 2019, we had version 1.4, and now we are actually working on version 1.5. This is a quick matrix of what Bigtop contains. These are the various components in Bigtop, and you can see you have various distros, and also different architectures like x86, ARM, and PowerPC. So you have the build and automated test all running in the CI. So here you have the distros, CentOS, Debian, Fedora, Ubuntu, OpenSUSE running across ARM, x86, and PowerPC, and some of the leading components of Bigtop. And here's what coming up in the next release, and the next release will be in next few weeks. We are already working on finalizing it and working through the kinks. So what's coming up in the next release is we have Elasticsearch included. That means Elasticsearch, Logstash, and Kibana, the whole stack. We have upgraded quite a few components, bumped Hadoop version to 2.10. We have bumped Spark, HBase, Hive, and so on. We have removed some of the obsolete components like Apex and Hama and Tahoe. So these are the components that industry is not using anymore and moved on to better components. We have quite a lot of integration tests, smoke tests added into this release as well. And of course, quite a lot of bug fixes too. And another component from the top to bottom approach that we selected was Apache Ambari. Apache Ambari is the only open source project out there now, which helps in provisioning, configuring, monitoring, managing, and also taking care of security of big data clusters. Apache Ambari was actually a Hortonworks backed project, and we have contributed quite a few projects to make it truly open source by removing some of the hard-coded dependencies to Hortonworks' own proprietary SDP distro. We also worked on making Bigtop integrate with Ambari by building something called MPack, which is a management pack. So Ambari can actually utilize Bigtop and all the components inside Bigtop and use it as a distro to provision a big data cluster and also manage the installation and monitor the cluster. Here's just general high-level achievements that we have done other than mentioned above is from build and port point of view, from bottom to top approach, we have been looking at each individual components and components like Apache Pulsar, Phoenix, NiFi, Airflow, Beam. These have ARM bits now available with all the patches that has gone into it. We were able to even set up CI with most of these projects thanks to Developer Cloud, and also an effort from a project called OpenEuler, which is actually backed by some Huawei folks, and their contributions towards this through a project, through an initiative called Open Lab. We have worked on setting up multiple workloads on things like Elasticsearch, Stack, H2O, and sparkling water, Apache Ambari, Apache Drill 2, and many of these have been showcased in the past in the Linaro Connect demos. We have spent quite a lot of efforts on benchmarking as well and finding areas where we can have ARM-specific optimizations. We have explored HiBench in particular with many of the big data components, ran benchmarks against them. We did with Spark Bench, we used TPC benchmarks and many more. And all this effort has been documented, and you can find that in our collaborate page. We also contributed towards ARM-specific optimization. One such example is what we did with the Apache Arrow project. And there was a talk provided by Yuchi earlier on, which goes into detail. And I would encourage, if you are interested, to go check that out. We also worked closely with University of Michigan, who actually used our who utilized our work that we have done with Bigtop in particular and Apache Ambari, and they were able to establish a production scale petabytes size big data cluster for their university workload. And these are the links of CI that's running across various projects that these run on ARM hardware in Developer Cloud and Open Lab. So moving on, so some of the pain points while we were working on this, what we have seen is, again, mainly, convincing the projects that ARM is actually production ready now. We had some issues with projects having the native libraries, not ready for ARM. We had issues, for example, with Protobuf. Protobuf version 2.6 onwards had ARM build, but majority of the big data projects had dependency on Protobuf version 2.5. So the issue was we were trying to talk to Protobuf, and it was impossible to convince Protobuf project to make an ARM build because they have moved on from version 2.5. And it was hard to talk to each individual big data projects due to the level of effort that they would need to test to upgrade to version 2.6. So now these things have been tackled and finally fixed. It took a while, and the major problem was talking to various projects and convincing them, and getting they're okay with it. And also, big data has so many dependencies at many levels. Sometimes we run into cyclic references. And for example, when a project A depends on project B, and then project B depending on C, and C depending back on A, if that happens, and if we have to upgrade one particular project, then you need to talk to all this other projects, and that puts us in a loop, and that was a problem as well. Another project, for example, was with Apache, Bazel. Bazel didn't have ARM build. Many of the data science projects depend on Bazel. So, making the Bazel and getting them to make ARM build took a while. And it took a lot of effort from Linaro's team, Packett's team as well. And then finally, we now actually have ARM build for Bazel. Now we can look into projects like Anaconda and TensorFlow and things like all these data science projects that depend on Bazel. So what are we working on currently? Again, majority of our work goes to Bigtop. We are working on version 1.5 currently. Um, and then beyond version 1.5, we have actually started to look at version 1.6, where we are looking into efforts like upgrading Hadoop to 3.0, and integrating OpenJDK 11. We are also working on making Ambari impact and moving it to top level in Bigtop. Um, we will continue to focus on bottom-up approach as well, looking at each individual projects and making sure they have ARM built. And we would like to set up workloads with these individual projects, because sometimes build goes well, but you don't see the issues until you set up the workload and make sure the integrations and configurations are all working. We have seen issues when that happens in the past. Sometimes when you run the workload, you notice some memory issues, and then we start debugging and work on fixing that. So we will also work on some of the security components, Ranger, Knox, and Atlas. And we have few issues that we are currently working on, related to Arrow, um, uh, and also RocksDB. RocksDB version 5.17 upwards, that means 5.18 and versions beyond that, has been noticed to have a performance regression. So some of the projects are trying to downgrade RocksDB to version 5.17. Unfortunately, version 5.18 onwards has ARM bits. So it is very important for ARM to focus on this and try to fix what is going on. So that's something we are also working on. And we are working on setting up some workloads with, Apache Airflow and Pulsar as well. Looking at our future work, like I said, we have Hadoop 3 upgrade, JDK 11 integration, Ambari impact work. We also need to add Kubernetes support to Bigtop and bringing more and more components, for example, Apache Beam, Arrow, NiFi, Presto, all these to Bigtop, and also some of the data science tool as well. We still have quite a few projects that we need to focus on from a bottom to up approach, and to make sure they have ARM artifacts available. And then we have some benchmarking and optimization works to do. We have tons of data science components that we need to focus on. And then we have this major effort that we need to focus on, which is HPDA, which stands for High Performance Data Analytics, basically running big data on HPC. Also, we need to focus on making big data run on RDMA. We think HPDA is going to have a lot of ARM-specific benefits. Now that we noticed over 23% of HPC system its actual usage is HPDA related. So it is very important for us to work on it. And RDMA as well. We think running big data on RDMA could give performance up to even 40%. So we need to focus on that. It's very important for us. So we have started to look into it and make our plans as per our roadmap. With that, that's the end of the presentation. And please ask your questions in Slack, or you can reach out to the email. Thanks to the team working on us, and thanks to projects like OpenEuler and even Packet for their ARM contributions.